So we're starting to get a sense of how these life cycle assessment calculations can be carried out. And I thought in this video we would actually look at some life cycle assessment results that have been published in the past to learn a little bit more about how this type of information can be used. One thing that we'll notice is that not only can you calculate an overall amount of impact for the production of a particular thing, one really nice characteristic of life cycle assessments is that you can organize this data by the different stages that go into the production of that thing, or you can break it down by process to learn more about how to make that thing more environmentally friendly. The aluminum can is a really good example of that. And here on the right, we have data from an EPA study of aluminum production. What they've done is they've broken their data into the different categories or different stages of aluminum production. We've got the bauxite mining here. We've got the process of turning bauxite into alumina here. We've got the process of turning that alumina into aluminum. And we have the casting of the aluminum ingots, which remember are just basically cubes of aluminum. We don't have the steps for the can here, but these early stages of the can process can tell us a lot about how to make cans in more sustainable manners. The unit of environmental impact we have here is a kilogram of CO2 emitted per metric ton of aluminum produced. So their functional unit here isn't a can. They've chosen just a ton of aluminum, but their environmental impact is the kilograms of CO2 that are emitted in each stage of the process. So if we take a look at this, we can very quickly identify what are the most energy and emissions intensive steps of the process, and what we see are alumina production and electrolysis really rise to the top. They make a large fraction of the overall environmental impact of our can production. And here's some additional data from the same life cycle assessment, which compares the production of cans from virgin materials, so basically making the aluminum from scratch, and comparing that to cans that were produced using completely recycled materials. And so once again, we're looking at greenhouse gas emissions. We're looking at CO2 emissions per ton of material produced. And what we have here is emissions resulting from energy use, emissions resulting from transportation, and other emissions that are released from the chemistry of making those materials. And we have values for making aluminum from scratch. We have values of recycled aluminum, and we can see the difference here. And we can see that because we're avoiding the alumina production and electrolysis steps of aluminum production, we save a lot of energy and we reduce a lot of emissions in the process. Okay, how about something that might be a little more closely linked to our daily activities? What if we compare paper and plastic bags at the grocery store? Which one is less impactful to the environment? So here we have a life cycle assessment carried out by Cal State Chico, and they compare a bunch of different grocery bag technologies, if you want to call it that. We've got our plastic bags, we've got paper bags, we've got reusable plastic bags, and we've got recycled reusable plastic bags. And we're looking at a couple different types of environmental impacts here. We've got energy use, we've got greenhouse gas emissions, and we have water consumption. And in general, what we see is something that might feel a little bit counterintuitive. We see that the paper bag is actually much worse environmentally by all three of these measures than the plastic bag. And a big reason for that is that paper bags require a lot more material in them, and that ends up resulting in more materials going into the manufacturing process, more energy being used for transportation, and more material being thrown away in the landfill at the very end. So in general, you're better off picking a plastic bag than a paper bag at the grocery store. If we're looking at reusable bags, yeah, these things work much better. But what we can see here is that they're much worse if you only use that bag once or twice before you go off and throw it away and buy a new bag. But anyways, I guess the best we can do is to use a recycled, reusable bag and make sure that we're organized and hanging onto that bag and using it every time. And here's an example of a life cycle assessment that compares many different life cycles and many different environmental impact measures. Here's a question, okay? You've got that old cell phone or you've got that old laptop computer. Should you replace it? Does it make a difference environmentally if you replace it? Might you even be doing the best thing for the environment by replacing it because you might be buying a newer, more energy efficient model? Well, here's a life cycle assessment that was published in a paper that I found that compared the energy use of these different electronics, and it compared what's called the embodied energy use to the use phase energy use, basically comparing the energy that goes into the manufacture of the product to the energy that goes into the use of the product. And what we see here is something that's actually pretty interesting. Even though laptops are constantly plugged into the wall and used on a daily basis, it's actually the energy that goes into its manufacture that dominates its overall life cycle. And this similar story for cell phones. The energy that goes into making the cell phone is much larger than the energy that the cell phone consumes over its life cycle. So the moral of the story is, in terms of laptops and smartphones and a lot of other components that make up our modern day internet system, you're much better off environmentally if you hang on to those devices for longer periods of time before they finally poop out. You don't want to replace them early. You want to hang on to them so that there's less energy going into making new laptops and new smartphones. Here's one that's related to a calculation we did in class. How do gas cars compare with electric vehicles? In class, we found that electric vehicles produce fewer emissions when you're driving them around town. But does the story change when you consider the fabrication process of the electric vehicles? Batteries are actually really energy intensive to make, and I wonder if that makes a difference. What we can do here is we can split up our life cycle information by the different phases of production. For example, we have the use phase of a conventional vehicle here, a battery electric vehicle and hybrid vehicles. The use phase is depicted in purple here, and all the manufacturing processes are depicted in these other colors here. And our environmental impact that we're measuring, once again, is greenhouse gas emissions. We can see that yes, the battery electric vehicle does require a lot more impact to manufacture in the first place, requires more energy and results in more greenhouse gas emissions. But when we're talking about cars driving around, it's the use phase that really dominates their life cycle emissions. And because electric vehicles are more efficient than conventional cars or hybrids, you're actually best off buying an electric vehicle. The use phase savings more than offset the additional emissions that are required to manufacture the car in the first place. Here's one around food. You can do life cycles on food as well. You can break up the food life cycle energy use into different categories to maybe learn more about how to produce food more energy efficiently. You can also compare different types of foods, and not surprisingly, things like dairy, eggs, and meat require more energy to produce over the life cycle of those foods. And a big part of that is because you have to constantly be feeding animals in order for them to produce things like dairy, eggs, and meat. You have to grow food for several months in order to get these types of products, whereas you only have to grow the grains and vegetables for a short period of time. You only have to grow them once in order to just simply eat the grains and vegetables right off the bat. So you're better off being a vegetarian, and you're best off being a vegan in terms of energy use to produce your food. This last example is actually a really interesting TED Talk, and I'll post this on our course schedule so that you can watch it if you like. What it does is it carries out a life cycle study of the energy required to rip an old house down and build a brand new one from scratch, and it compares the energy use for that process to the process of simply insulating and updating an existing house, an existing older house. Turns out that the moral of the story is you're better off, at least in this case, just demolishing a house and building a really nice new energy efficient airtight house from the ground up. Okay, so what we have here is some examples of how life cycles are used. In our next class, we're going to dive into the data of an MIT life cycle study on different hand drying technologies to see if we can learn anything that could be applied here at Allegheny. And after that, we're going to start using some fairly sophisticated software to carry out some of our own life cycle assessment calculations. Okay, I think we will leave things there.